Jonathan, the floor is yours, please.
Thank you and good afternoon. I assume that much of the science will be familiar to many people in this room anyway, so I hope I pitched this at roughly the right level. I think it's important we do start with the science, just as, if nothing else, as a reminder as to why we're here and what the scale of the challenge is. And while Copenhagen didn't succeed, the reason why we set the date as Copenhagen to make some real progress is there is a time limit on this problem, and the time limit is coming up pretty fast. Well, just to start with, where are we? Well, little has changed in the science over the last 12 months, and some of the best, most recent science reports came out at the end of last year, just before the Copenhagen summit. So that's what I'll dwell on today. I'll dwell on the science since the last publication by the International Panel on Climate Change in 2007. Two major reports which I'll be referring to. One is the Climate Safety Report, which many of you will have seen back in the end of 2008. And then at the end of last year, NASA produced a report which was a work of 26 scientists together called the Copenhagen Diagnosis. Now you can find that on the web. Unfortunately, the link from the NASA website doesn't work anymore. But that gives a fair flavour as to where peer-reviewed science was a year ago. Much of the news this year has been displaced by things like Deepwater Horizon and BP and so forth. But the science has not changed. So just to summarise where we are. This was Heathrow. This was we are armed only with peer-reviewed science. So we do use peer-reviewed science as our basis. The science I'm going to show you today is not anything except that which has been agreed and approved by the scientists. To start with some of the issues from the Climate Safety Report. We know that sea level is an issue, but there's also the ice on the North Pole, which is reducing. That reduces the reflection of the solar rays back into space. So this reduction of ice, what that does is keeps more heat in the Earth's atmosphere, which again can contribute to the speeding up of the temperature. Now, for me, this is one of the most shocking slides in the Climate Safety Report. What that shows is that this is a graph of the speed of ice melt and prediction minus 100% from today means at what date do we think all of the ice at the North Pole will be gone. Now, all of the reports by the International Panel on Climate Change up to 2006 in Science in the 2007 report suggested we're looking at about 2075 or onwards. The current rate of melt suggests that we're going to hit that somewhere between 2015 and 2020. So that means that all the work that the scientists are doing, on which the politicians at Copenhagen base their discussions, were wild out from what's actually happening. And the reasons for that are that the science is not just a linear thing. It isn't just do this in terms of CO2 and the temperature response. It's more complicated than that, and it's actually making it worse rather than better. This is just to say the amount of CO2 in the atmosphere is an amount. If we put all fossil fuels into that as well, and it will go up by a lot. But there's other CO2 sources as well. There's lots stored in the permafrost below the tundra. So the risks are much, much bigger than what we might imagine. And just a point on risks. The Climate Safety Report and right back to 1992, the ultimate objective was to stabilise greenhouse gas concentrations and to prevent dangerous anthropogenic interference with the climate system. There's wide agreement with scientists that if it goes above 2 degrees warming, that's what we'll get. But we don't know how we achieve that. All the models aren't sure as to how much warming we need to get to that number. There's a risk element. And this was just to summarise, the key issue is the amount of CO2 in the atmosphere, not the amount which we emit each year, because it's the amount in the atmosphere that causes the global warming effect to take place, not the amount we add to it. Each year we add more emissions into the atmosphere, and some of that is taken out by absorption by trees and forests and so forth, and the oceans. But that's the problem. And the problem's bigger than what we imagine, because a lot of the amount of CO2 in the atmosphere is masked by other particles in the atmosphere which reduce their effect. So currently, we aren't responding as quickly as we might by what's there. CO2 is going up, methane is going up. The reason for focusing on CO2 is that's the one that stays up there. Methane deteriorates into CO2 with time, but CO2 persists in the atmosphere. And that's the temperature graph, it's going up. There's been disputes about things like solar influence. This slide just shows that human influence temperature is rising, but that due to solar influence is smaller and varies with time. When the raising temperature melts ice, that causes sea level rise, and that's just to show observations and predictions of what's happening there. Again, you can see the actual observations are at the worst end of the predictions in the climate science models. This is two pictures of Greenland from 1997 and 2007 showing the areas which are melting. Those areas are increasing. It's a big country. It's got over 3,000 metres thick of ice. That is melting. It's quite severe now. If you're actually on the ground, this is a picture going back from 3 or 4 years ago. It's quite colossal amounts of water are coming off that continent. And if that all melts, we'll have 7 metres of sea level rise that will have a massive impact. Why 350 degrees? Why is there a campaign for 350? Well, the climate science summary there suggests, I'll just summarise the words, because the current approach by the climate scientists at the International Panel on Climate Change have neglected feedback effects. James Hansen and others from NASA have included that modelling, and what that showed was that if we have all of the ice sheets melting, there isn't a possibility other than we get runaway climate change. i.e., the more ice sheets melt, with time, temperature will go up, and whatever else we do will end up with runaway climate change. So we need to save the ice sheets and have policies to do that, regardless of what concentrations we aim for, what targets we commit ourselves to. The question is whether we have those ice sheets or not. And the modelling from James Hansen suggests that we need to actually reduce the amount of CO2 in the atmosphere. It's currently in the late 380s, early 390s, downwards rather than allow it to increase. So not only in time have we got to stop the emissions going up, we've actually got to bring them down again. And what that says is we can talk about CO2 emissions, we can talk about CO2 concentrations, but ultimately the challenge is to stop the ice melting so we don't have runaway climate change. This modelling from just before Copenhagen talks last year is modelling the amount of CO2 in total which we emit and by different years, and what this is looking at what happens if we emit 1 trillion tonnes of carbon. The reason for focusing on that is this scientific report, which fed into the Copenhagen diagnosis report, was saying that if we emit more than this amount, then we are of a more than 50% chance of causing runaway climate change. Now, that is not a large amount. So what we're talking about there is when will the 1 trillionth tonne of CO2 since the Industrial Revolution be emitted, rather than what will the emissions be like on a certain date. So the climate challenge is how quickly we reduce to zero our climate emissions such that we stop emitting carbon as a planet before we can't deal with the consequences. So the challenge is when we stop. The problem is the later we stop, as this graph shows, the steeper the reduction which is needed. If we leave it till 2020, if you look at that, this is a global graph. Globally, we will have to very, very quickly reduce CO2 emissions to around zero by 2040. If we start earlier, we can do it slower. That global reduction from 2020 is 10% CO2 reductions per year. Now, we achieved 1% reductions per year in the UK when we switched a lot of our electricity supplies from coal to gas, and the French did when they switched theirs to nuclear. So a 10% reduction per year across the whole of the planet from 2015 onwards, all the way through to 2045, is a big challenge. And the biggest problem is we're not currently reducing by 10% 10% a year. We've averaged around 3% increases, 3% per year increase in CO2 emissions across the planet over the last 100 years, and it's been speeding up over the last decade. Now, Stern said that we needed to have a 1%. He assumed that it was going up by 1% per annum. It's actually going up by 3% per annum. So the economic forecast, even by the economic experts, actually got wrong what's actually happening. And this is what's causing it. This is a city called Chongqing. It's in the middle of China. It's 30 years old. That was the middle of nothing. So when you think of a developing country increasing its emissions, don't think of a poor village in the middle of nowhere. Think of us, because they're becoming like us. The challenge is, how do we shift from growing at 3% a year to reducing at 10% a year, such that we meet science, and globally we peak our emissions by 2015 and then reduce rapidly. So at that point, what I was going to do is just to summarise how the Copenhagen diagnosis summarised things at the end of last year, and perhaps that will set the scene for the rest of this afternoon. In 2008, was 40% higher emissions than in 1990. Even if global emissions stabilised at present-day levels, just 20 more years of emissions would give a 25% probability of runaway climate change. Over the past 25 years, temperatures went up by 0.2 degrees a decade. A wide array of satellite and ice measurements on Greenland and Antarctic ice sheets show they're losing mass at an increasing rate. Summertime melting of Arctic sea ice has accelerated far beyond the expectations of the climate models. Global average sea level rise is expected now to be 80% above the past IPCC predictions, consistent with a doubling of the contribution of melting from glaciers, ice caps, Greenland and Antarctic. The predictions of sea level rise are 2 metres of sea level rise by 2100. Now, just to put that into context, the reason I'm standing here is 5 years ago I was working in Bangladesh, and a 1 metre rise in sea level will turn the average annual monsoon, which is currently a 1 in 50-year monsoon, which covered 80% of the country with water in the monsoon season and killed 300,000 people in 1970. A 1 metre rise in sea level would turn that into the average annual event. So a 2 metre sea level rise would be catastrophic, not just for Bangladesh, but for many countries and cities within a metre of sea level around the world, and that would include places like London. There are several vulnerable elements: ice sheets, rainforest, monsoon, which will be pushed abruptly or irreversibly if this continues. Global emissions need to peak between 2015 and 2020 and then decline rapidly. So we've got a decarbonised global society with average annual per capita emissions well under 1 metric tonne of CO2 by 2050. That is an 80 to 95% reduction in emissions in developed countries. So, to summarise, if economic growth is not possible with 20% per annum CO2 reduction, then we need a planned economic contraction to stabilise at 2 degrees centigrade. That was a conclusion of Kevin Anderson of the Tyndall Centre in the UK. Now we're in a recession, so I think the challenge for us is, rather than think about green jobs as some way to restore growth and business as usual in a better, more climate meaning way, we need to have a rapid shift, because the challenge is not small, the challenge is massive. The challenge isn't just for the UK, it's for the world. How do we get China to stop building cities like that? Well, the only way we can do it is if we show that by acting today, by 2015, every country in the world is following our lead. Thank you.